Okay, here we are at section 13.6. This is the beginning of it. If you remember, on Friday, this past Friday, we actually, at least in the one class, actually it wasn't Friday, I think it was Thursday, we did this because Friday we had prom and we didn't do a whole lot in class Friday. So it was on Thursday. I couldn't get the pen to work very well, and I found out later it was the battery. But we just did this on the board, so it wasn't recorded. So I figured, let's just record it so that if you need to look back on it and figure out why some of this stuff is true, we can do that. Alright, so first of all, what we're going to do, we had mentioned before, let me just write it down so that you remember. We had mentioned before that the sine, and let's try this again. Alright, let's go cosine. Alright, so we said that the cosine and the sine can be written as an ordered pair, just like x and y could be written as an ordered pair. We said that the sine or the cosine and the x went together, or the x equals the cosine of the angle, and we said that the y and the sine go together, which means the y equals the sine of the angle. And I didn't really give you any great explanation. I really didn't give you any explanation. Some of you guys were bothered a little bit by that fact, but I said, well, wait till we get to the unit circle, because I like to teach the unit circle as early as possible, because then it gives you some ideas of why this kind of stuff is true. And I just wasn't real happy with how the book presented it, so that's why we're doing it now. Alright, so let's take a look. Y is the cosine equal to the x, and y is the sine equal to the y. Well, I'm not even going to go on the x and y axis right now to start this out. What I'm going to do is go, just draw any random angle from the origin. I'm going to stay in the first quadrant just to make it easy. Alright, and I'm trying not to make it, anything particular. Let's just make it right here. Alright, and we're going to take that angle and we're going to just drop down a perpendicular to the x-axis. Remember, that's how we're always going to do this. We're always going to take the make a right triangle so it comes down to the x-axis. Alright, we have now an angle. We'll just call it theta. It's an unknown angle. This can work. This works for theta. It'll work for any angle. And it's a right triangle because we drew it perpendicular to the horizontal. Alright, let's do this. This is a unit circle. We talked about this the other day, and I'm just referring to it again. So the unit circle is really helpful when it comes to this stuff. Big fan of the unit circle. So here we go. Let's just talk about the length of this side and the length of this side first, because really what we're doing is we're trying to find what that ordered pair is right there at that point on the circle. So if you start here, how do you get to that ordered pair, or how do you get to that point on that circle? You go to the right and you go up. Well, this direction, we're familiar with that enough, and even right here it even says it's the x-axis. So we call this length x, and we'll call this length, obviously it's parallel to the y-axis, we'll call this y. So really this ordered pair then is xy. For instance, if you went like over 5 and up 3, you would call that thing 5, 3. That's the same thing. We just don't know how far over and up we're going because we don't know what the angle is. But we do know we go over x amount and we go up y amount, so we call that ordered pair xy. Well, let's think back to our trig functions, our SOHCAHTOA. Let's do the sine of the angle, let's do the cosine of the angle, and let's do the tangent of the angle, and let's see what we get from stuff that we already know. We already know that SOHCAHTOA. So let's do the sine first, since that's kind of in order with our SOHCAHTOA thing. So the sine of this angle is the opposite over the hypotenuse. Now remember what we said, this is a unit circle. Unit means 1, so we're going to make the radius 1. We discussed that previously. So the radius of this circle is 1, that means the hypotenuse to this right triangle must be 1 as well. So what we're going to, let's go back to the sine. So the sine is the opposite over the hypotenuse. So it's going to be y, which is the opposite side, over 1, which is the hypotenuse. Obviously, 1 over, or y over 1 is equal to y, so check it out. Y equals the sine of theta. Alright, that's why they go together right there. It's exactly why. Y equals the sine of theta. Let's do the cosine. The cosine is the adjacent over the hypotenuse. And check that out. That's y, or x, sorry, over 1, which equals x. So look at it. X equals the cosine of theta, just like we said earlier, but we never really gave any good explanation. I think this right triangle in this unit circle gives you a great explanation to why x equals the cosine and why y equals the sine of the angle. What about tangent, though? Tangent's not quite so easy to see in here. You don't just look at this and say that's the tangent or that's the tangent. Remember, the tangent is the opposite over the adjacent. So if we use those sides that we've been given, we'll say it's y over x. Now what did we just establish? We just established that y is equal to the sine of the angle and that x equals the cosine of the angle. So we could write it in terms of sine and cosine. So the tangent, you could say it's y over x, sure, or you could say it's the sine of the angle divided by the cosine of the angle. Alright, so there you go. So the sine, let's do it this way. We'll go x then y. X equals the cosine of the angle, y equals the sine of the angle, and the tangent is the sine over the cosine. Alright, let me pause, get rid of this, we'll clean it up a little bit and do some things right on the x and y axis. Okay, I got rid of all that stuff. What we're going to do now is we're going to look at this unit circle and we're going to look at the quadrantal angles. That's the way the book refers to it. Basically, they're the angles that are right on the x and y axes. Okay, so we're talking about an angle right here. We'll just put a point to represent where that is on the circle. Now remember, we're going to write this as an ordered pair, just like we did up here when we put that thing up here. But now remember what we already know. We already know that if this is xy, that's the same thing as the cosine, I'll leave out the theta, and sine. Remember, they go together. So whatever the x value is, that's what the cosine is. Whatever the y value is of this point right here on the circle, whatever the y value is, that's the sine. In order to find the tangent, you take the sine over the cosine or the y over the x. So let's do this. Let's find an ordered pair. Now you don't even have to draw a triangle on this. In fact, you can't draw a triangle on this. That's why these are kind of special. We start off with these things. So, but we can figure out what the ordered pair is. Remember, this is a unit circle, so the radius is 1. So from here to here is 1. So if that's what I did, if this was just like a regular normal xy axis, and I said, okay, go to the right one, what would the ordered pair be at that point? Well, that would be 1, 0. Now check it out. It's 1, 0. 1 is the x, or 1 is the cosine. So the cosine at, let me put an angle here, the cosine at 0 degrees is 1. So let's write that down. The cosine of 0 degrees is 1 because x equals the cosine of the angle. X is 1 in this situation right there, so it's equal to 1. Let's do the sine. Okay, so the sine of 0 degrees. The sine of 0 degrees is the second one. It's the y, because y equals the sine of the angle. So the sine of the angle equals y, which is 0. It's just plain old 0. It's not 0 degrees, it's the number 0. And let's do the tangent. The tangent, we have to think a little bit about it, but we've already talked about this. We said the tangent is the y over the x, or the sine over the cosine. So let's do it. It's 0 over 1. 0 over 1 is equal to 0, and that's the tangent. So we've got the sine, or the cosine, the sine, and the tangent of these angles. Let's do it again for these angles up here. We'll try to go a little quicker. So this is now 90 degrees. We find the ordered pair. That's what's important here. What's the ordered pair if the radius of the circle is 1? Well, if you just go straight up, you went 0, 1. Now check it out. It's the cosine of 90 degrees, the sine of 90 degrees, and the tangent of 90 degrees. We can figure that out just with a little circle with a radius of 1. The cosine is the first one. Okay, it's the x, so it's 0. The sine is the second one, and that's a 1. The tangent is the y over the x, or the sine over the cosine, so that's 1 over 0. Now this is a little odd. Alright, 1 over 0 doesn't actually work. You put it in your calculator, it'll tell you error, so it's undefined. I'm going to write it like this, or you can write the word out undefined if you like. But I'm going to write it like this. It just means empty set, does not exist. Alright, so there is no tangent of 90 degrees. It does not exist. It's not a 0. It doesn't exist at all. So that's the cosine of 90, that's the sine of 90. And you can do it for the rest of these. Let's do this real quick. It's 180 degrees. The ordered pair is negative 1, 0. So the cosine of 180 degrees is equal to the first one, which is negative 1. The sine of 180 degrees is equal to the second one, the y, which is 0. And the tangent of 180 degrees is equal, put a degree symbol there, the tangent is the y over the x, so it's 0 over negative 1, which is 0. So you've got your 3 here. I think we have time to do one more. We'll do this one right here, which is 270 degrees. Let's do the cosine again. Actually, let's do the ordered pair first. Ordered pair is important. So how do you get from here to here? You go 0, negative 1. That means the cosine of 270 degrees is the first one. It's 0. The sine of 270 degrees is the second one, which is -1. Try this in your calculator and see if I'm not telling you the truth. The tangent of 270 degrees is the y over the x, or -1 over 0, which again you can't divide by 0, so it's undefined. Alright, so we did it for the 4 quadrantal angles, and that's about it. Okay, I think that should clear it up a little bit, and it should kind of prepare you for the next 2 lessons if you haven't already seen them. Alright, that's it. Thanks. Bye.